The work-energy theorem, also called work-energy principle, states that the net work done on an object is equal to the change in kinetic energy of the object. In this video, I am going to derive this equation. I am considering an object. The object is in a one-dimensional motion, moving with a constant velocity v0. Since the velocity of the object is constant, its acceleration is 0. Newton's second law says the net force on an object is equal to mass of the object times its acceleration. Since the acceleration is 0, the net force on the object is 0. Note that the net force is the sum of all the forces acting on the object. So the net force is 0 doesn't mean there is no force acting on the object. There may be forces acting on the object, but if you add all those forces, you will get 0. The object is moving, and when it is at this position, I am applying a force on the object. Since the net force is 0 before this force is applied, now the net force is equal to this force. Due to the net force, the object is now accelerating. So its velocity changes. I am keep applying the force for a time interval delta t. At the end of the time interval, the object is somewhere here. At this position, let the velocity of the object is v. When the force started, the velocity of the object is v0, so I take v0 as the initial velocity of the object. nv is its final velocity. And the displacement of the object is delta x. Now, let us find the work done on the object in the time interval delta t. For simplicity, I assume that the net force is constant. Work by a constant force is the force times the displacement times cosine theta. The force and the displacement are in the same direction. So, theta is 0, and cosine 0 is 1. By Newton's second law, the net force is mass times acceleration. Next, I'm going to use one of the kinematic equations, which is final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. Next, I am solving this equation for a delta x. So, move v0 squared to the left-hand side. And divide by 2 is equal to a delta x. Now substitute this for a delta x is equal to 1 over 2 m times v squared minus 1 over 2 m times v0 squared. This is the final kinetic energy of the object, and this is the initial kinetic energy of the object. Final kinetic energy minus the initial kinetic energy is the change in kinetic energy. So, the net work done on the object is the change in kinetic energy of the object. Thus, we derived the work-energy theorem. Note that, although we derived this equation with the assumptions that the motion is one-dimensional and the net force is constant, this equation is valid for any force and any type of motion.